Hi, good afternoon, everyone. Hi, Jen V. Chitradurga. Okay, so hi, YouTube people. Just wait a minute. Okay, we are good to go. I'm again sharing this. Okay. Okay, now we're good to go. Okay, so before continuing the class, I just let me know, am I audible or visible to you? Let me launch the poll. Okay. So only Chitradurga, Jen Chitradurga is present. So just let me know. Okay, so there is no issue from Chitradurga. Okay, so let's wait for some time and after that we'll continue. Na? So YouTube people, everything is fine. Okay, so let other to come. Let's wait for some time. So I hope this is your first class of chemical kinetics, right? So Jen B. Chitradurga, just let me know, this is the first class of chemical kinetics, right? We are starting this class today, or it is already taken some introduction class. Area, please just let me know. To okay, so let's continue. Okay, just be with me. And so before continuing, so just let me give some certain introduction for myself. Okay, so myself Lachu Naik. Okay, and I am from Odisha, and currently I am staying in Genvi, Mysore, Karnataka. Okay, and because Gopi sir has some work to do, so that today I'm taking your class, and perhaps some classes I will take. After that, you will continue. Okay. So let's continue. So the first class of chemical kinetics for 12th class. Okay. So let's proceed. So this is our chemical kinetics. So like when we are dealing, chemistry means what? Chemistry means changing. Chemically something you change, that is called chemical reaction, or chemistry is all about the new thing. Okay, so production of new thing, that is chemistry. Okay, so what is chemical kinetics? Okay, so let's understand that. So chemical means, we know this now, this chemical substance, that is chemical. And what is kinetics? Okay, so kinetics means it is coming what that is called. So here in this chapter, we will discuss about some changes, okay, or rate of change, like at which rate they are changing. Okay, we can say for particular changing, how much time they are taking. Those are things. Today we are going to discuss about this chemical kinetics chapter. Okay, chemical kinetics chapter. For example, if you're taking this one, this we know this, like everyone can see this one. This is a car. Okay, so this is moving, and to movement of this one, it needs some fuel. Okay, and perhaps you know this, we have different type of fuel: petrol, diesel. Now we are using CNG. Okay, and some like some vehicle they don't use petrol, and some they don't use diesel. So why these things happening? Why we have different type of fuel? Okay. So because we know this, they give us different type of power. That means what? Whatever the rate of consumption or capacity of those fuel, that those are different. Okay. So this chapter we are going to study what is the rate or consumption rate, how they consume. Okay, per unit time. Those are things today we are going to discuss. Okay. So actually we are discussing about the movement. Okay, like here you can see we have two particles, they combine to form some product. Okay, so here we are going to discuss about what the speed, what is the speed at which they are collide to give us the product. Can we change their speed? If we can do, then what are the factor on which we are like keep in mind? Those are the things here we are going to discuss. ठीक ना? So everyone understood this? Like what is the importance of chemical kinetics? Okay, why we study this? Okay, so before that one, let's take some another example. Okay, so there you can have some clear idea. Okay, clear idea. So let's take this one. So what is this? Can you tell me what is this one? So you are wondering why sir is asking this one. Everyone is know this one. What is this? This is diamond. This is diamond. Okay. And what is this? This is coal. Everyone you know this coal. So what is the relation between them? What is the relation between them? We know this coal can be converted into diamond. That means what? That means what? So like anyone can wonder, can we convert what pencil na graphite within that one? So can we change that graphite within that pencil into diamond so that we can tell we have a diamond pencil? Okay, and with the diamond pencil we can cut any glass, hard glass. So can we do this? Like, can we change the graphite within our pencil into diamond? Yes or no? Can you tell me, anyone? Like, can we change that graphite or no? Okay. So let's see whether we can convert that graphite into diamond or no. Okay. If we can do, then we can be rich within overnight. Overnight we can be rich. Okay. So let's study that thing, like whether it is possible or not. Possible or not. Okay. Like we have already discussed, to convert coal into diamond, we need a high pressure and high temperature. Okay. We can say this is high pressure and high temperature. If we can provide this condition to a coal, okay, or graphite, we can have diamond. We can have a diamond. Or if we see their value, okay, their value, like high pressure means it is approximately 5 into 10 to the power 9 Pascal. Okay, and this is approximately, we can tell like this much Kelvin. Like you can say they are high value. Okay, these are the high value. And if we can provide this, we can convert them into coal into diamond. Okay, that means what? If we can understand what are the thing actually happening within microscopic level, then we can alter the thing. That means if we have some coal or graphite, and if we somehow provide this much of temperature, pressure and temperature, then definitely we can convert that into diamond. Like perhaps you have heard of that artificial diamond. They're converting those things by this method. Okay, so in this chapter, we're going to discuss what is the time it will take for conversion of particular thing. Like we know this, now to convert this coal into diamond, it's take plenty of years. Okay, many years to convert this conversion. Okay, it's a time factor. Okay, so here we come to know we want to study the time, like how much time it will take, and we are going to study the factor which affect that conversion, so that we can alter those factor, and we can have our product. Everyone understood this? So that is why this chemical kinetics chapter is important. Okay, so here we are going to discuss about this speed and factor affecting particular reaction or particular chemical change. Everyone understood this? Okay, so these are the thing. Okay. For example, everyone you know na urea. Okay, urea. We can say urea. This is a fertilizer. Okay, and we can produce this from ammonia. Okay, and this can be produced from nitrogen and hydrogen. So like we are a science student, okay, or anyone who try to produce NH3, okay, NH3, he wants to know if we take some particular amount of nitrogen and hydrogen, then how much ammonia it can give us. Okay, so in this chapter, we are going to discuss, okay, like what is the time it will take for completion in particular reaction. Okay, these are the things today we are going to discuss. So let's take this example only, like nitrogen react with hydrogen to give us NH3. Okay, so this example only. In this chemical reaction, for any chemical reaction, we need to know three things. One is feasibility. Feasibility means whether the particular reaction is taking place or not. I mean, suppose you are taking those coal, it will convert into diamond. So this is like it is possible. Suppose you are taking some plastic, so can it convert into diamond? No, it will not. So the feasibility is not there. So, and how to know whether the particular reaction is feasible or not? This we can know from the subject of thermodynamics. Perhaps you have heard of this. Gives free energy, that is denoted by delta G. So this value, if this value is negative or less than 0, okay, then we can say this particular reaction is possible or feasible. Okay, like suppose you put petrol with fire, then this is feasible. Okay, it will proceed. And suppose you put petrol with water, it will not proceed, it will not burn. So this is not feasible. Okay, so in the case, suppose there is a reaction which is feasible or proceed, for that one delta G value is negative, less than 0, and if that is greater than 0, that is not possible. Okay, after that, suppose we are taking this one NH2 which react with hydrogen, and this will give us NH3. We know this is like it will proceed, it's possible. So if we balance this one, how to balance this one? We have 2 nitrogen, put 2 here. Now we have 6 hydrogen, so put 3 here. It's a balance one. So now we come to this is possible. If possible, then can we tell like how much ammonia it will give us? Yes, we can do if we study the chapter of equilibrium. So this chapter will tell us what is the amount of NH3 you will get if particular amount of nitrogen, hydrogen if you take. Okay, and how you can increase the productivity of NH3 by varying the concentration of nitrogen, hydrogen, we have already discussed. Okay, and you can understand this thing from the chapter of equilibrium. Okay, now last thing. Okay, now we come to know this is particular reaction is possible, and if possible, we have some amount we can produce. So now can we tell what is the time it will take? Okay, or can we reduce the time or increase this time? So to understand this one, this particular rate or speed of this reaction, we have to study the chapter that is called chemical kinetics. So in this chapter, in this particular chapter, we are studying the speed of any reaction. Speed means with time, what is the change? अगर कोई थोड़ा टाइम बदलते हैं तो within that time interval, what is the change of particular reactant or product? So here initially we have taken some amount of NH2, some concentration of nitrogen and hydrogen. After some time it will produce ammonia, so their concentration will reduce. Okay, so now by measuring the change in concentration in the time, we can come to know what is their speed, at which rate or with which speed they're reacting. Okay, that is we are dealing in this chapter that is called chemical kinetics. Everyone understood this, the importance of thermodynamics, equilibrium, and chemical kinetics. And totally we are focusing on this chemical kinetics or speed of reaction. Everyone understood this? If you do, just let me know so that we can proceed for the next concept. सभी को समझ में आया क्या? कोई एक बता दो समझ में आया कि नहीं? चित्रदुर्गा जैन बिरेड we have to जैन. ठीक है? I hope you understood this one. This is simple concept. Okay, so अभी तो ट्रेलर है. Now let's see the whole movie. Okay. So before continuing, like we are supposed to know now what are the things today we are going to discuss. So in this class today we are going to discuss rate of the reaction. Rate, you know na, like what is the rate means with time what is the change, that is rate, and factor affecting the rate of reaction. Okay, like factor affecting the rate of reaction means that whatever the rate we are studying, can we make it slow, fast, moderate? And if we can do this one, then which factor we are keep in mind, like pressure, temperature, catalyst, everything. What are the things? Those are things we are going to discuss in the factor appearing ROR. Rate law. Rate law means it is the way of writing. And suppose we have any reaction and their speed, how we can write. That is the way of writing, we can say. Okay. Molecularity, this will tell us, suppose you are taking some amount of, you can take this example of nitrogen, hydrogen only. We are taking some amount of nitrogen, some amount of hydrogen, they react to give us product. Okay, so molecularity will tell us how many atoms they combine or collide to give us product. Okay, and mechanism reaction means how they proceed, Okay, like you burn a paper. So what is the mechanism? First you light on this matchstick, after that you put on fire on the paper. Okay, that is the mechanism. Mechanism means step, how you proceeding, that is steps. So these are the things today we are going to discuss in this chapter, chemical kinetics. ठीक ना? So let's proceed with one by one. ठीक ना? First, rate of the reaction. So what is the rate of the reaction? Like name this suggests ना, we are try to measure speed of any reaction. ठीक है? Speed of any reaction. Rate means speed. ठीक? Suppose this one. Okay. For this vehicle, suppose it was initially at A, and after some time it reached to B, unless the distance between them is 100 meter, ठीक ना? And it's take 20 minutes to cover this distance. Then what is the speed of this car? Simply we can find out speed equal to distance by time. So what is the distance here? Distance is 100 by 20. This is 5 meter per minute. ठीक है ना? Per minute. This is the speed of this car. Simple thing. ठीक है? So this is for any work or mechanism type. Okay. Everyone understood now how we find speed of this one? Simple thing, like we have studied in junior classes 11 and 10, how to find out speed of any vehicle if you are given distance and time. Okay, this is a simple thing. So we can tell, to find out speed of this car, we have to take the change in position. What is the initial position? Sorry. Whenever you take change, you have to take final by initial. Final position minus initial position by total time. Okay, and if you're talking about any chemical reaction, for this one, rate, we denote rate, that is change in concentration by change in time. What is the final concentration minus what was the initial concentration divided by total time, that is the rate of any reaction. Simple thing. Okay. So for any chemical reaction, rate of the reaction is concentration over time. Okay, like here you can see, no? So here is our concentration. Okay, so here here we have concentration and time. Unit is concentration or time. Okay. So concentration can be written mole per liter. You can take other concentration also, like that kg per kg, those also, but this is convenient one is mole per liter, but you can take other concentration also. Okay, and time you can take hour, minute, second, anything, but conveniently we are taking second only, na? So that is why unit is concentration or second. And suppose you are taking that change in pressure. Okay, suppose you are taking that like we have some, like if you want to find out change rate of any particular chemical reaction, initially we have some pressure and it changes to some final pressure. So because here we have changing the pressure, so we can write rate of the reaction with respect to pressure also, that is atmospheric per second, or you can take other unit also like Pascal, torr, other also, but conveniently we are taking atmospheric pressure per second. Okay, so these are the things. So everyone understood this, what is rate of the reaction and how we can find out, how we can calculate. Everyone understood this? ये समझ में आया सभी को? Okay, so let's proceed. Okay, now, so now we have come to know, we have now like in this chapter, we are going to discuss what speed of any reaction. So we can classify this reaction according to their speed. Some are too slow, some are too fast, some are moderate. So let's see one by one. Okay, like if you see the total na, that they are moving very slowly. Okay, and Usain Bolt is running very fast. Okay, so based on this, if we comparing the speed of any reaction, we have fast reaction, moderate reaction, and slow reaction. Okay, so let's discuss or see one by one. In first reaction, suppose you are taking any chemical reaction. For example, you can see here Excel with indicator. Why you use the indicator? So this indicator will indicate you whether the particular reaction is taking place or not. Okay, so we have indicator in bike, it will indicate. So simply indicator, those are some color substance. Okay, so while there is chemical reaction taking place, they will change their color. Okay, na? So suppose you have taken HCl, and anyways, if you put them, they will react spontaneously and they will give you some salt. In this case, they will get you NaCl salt. Neutralized solution. After that, so why this is your fast reaction? Because whatever the time they're taking, that is too small. Okay, so that is why rate is high. So this is called fast reaction. And example, we can take acid-base reaction. Any other chemical example you can take, chemical reaction. Those are fast reaction. ठीक ना? So chemical reaction. After that, let's see moderate reaction. Moderate reaction, if you take peroxide, hydrogen peroxide, okay, and if you leave this one, it will decompose into water and oxygen. So because why this is called moderate? Why this is called moderate? Because it will not take too much time, or it will not take, like, it will not occur too spontaneously. Moderate and in between. So that is why this is called moderate reaction. ठीक है ना, इसका moderate reaction होता है. Okay, you can take example of this one. And inversion of cane sugar. Inversion of cane sugar and hydrolysis of starch. That so sugar only. Okay, but hydrolysis, adding water. Okay, inversion you will study in organic. Okay, of cane sugar. It conversion only. ठीक है ना, inversion. So there is some changes, chemical or physical change for this cane sugar is inversion. ठीक है ना. So these are the some moderate example of some moderate reaction. So we have seen the fast reaction, moderate, and see the slowest. See this one, this I think this is car. Using this car, I don't remember actually this name. Okay, so this is a simple new one. Okay, and after some time it rust. Okay, or you can say the ring of that tire. Again, not ring, but I don't remember now that particular name. Okay. Now you can see the difference. When there is new, it is shiny appearance. Okay, after some time, many time you can say, after passing of many time, it become rust. It rust, and whatever the glowness of this one, it will lose this one. So rusting. So this rusting process here, whatever the time, if you see the while this changing from this to this, it takes too long time. That is why this is called slow reaction. Okay, and the rate of reaction is very slow, very small. Okay, like it takes too long time, but whatever the change you will take, you see that is small one. So that is slow reaction. Okay, slow reaction. Or we have discussed about conversion of graphite to diamond. It also takes plenty of years. Okay, or the rusting of iron rod. Perhaps you have seen, if you don't paint them, okay, then it will rust. Okay, so these are the some example of slow reaction. I hope you've understood first reaction, moderate reaction, and slow reaction. I hope you understood this. Simple side, ठीक है ना? Just think of any other reaction which are coming in this category, like fast, moderate, and slow. ठीक. After that, so we have seen the different type of rate of reaction. Okay, now let's see how to calculate the rate of any particular reaction, or we can say speed of any reaction. Let's consider we have one reaction in which reactant is converted into product and we are writing R is converted into P. R into P. So rate of disappearance of A, like what is the speed or rate with which R is consumed or disappears, that we can write change in value of R, concentration of R with respect to time. Okay, this is for reactant. Because the concentration of R is reducing, that is where we put minus sign here. Because if you see the change, this is reducing, na? So that is why we put minus sign, so that whatever the rate we will get, that is positive. Don't worry, mathematically we will discuss this later also, but just keep in mind this one. Because concentration of R is reducing, or the whatever the amount you are taking, that is reducing. So that is why we put minus sign here while we are writing the rate of this particular reactant. And for this product, because concentration of product is increasing, so we can put plus sign here. So this plus sign indicate there is increasing in the concentration of P or product, and minus sign there indicate there is decreasing in the concentration and decreasing in the value. Decreasing in the value. Okay. So now if you see this one graph, okay, graph. So we can see this this color blue, I think dark blue. It will its value is reactant, or reactant or product. This product. Okay. Actually, this one, as is reactant, its value will decreasing. Okay, I misplaced this one. So this reactant, its value, it is reducing. Okay, and product, its value is increasing. Okay, so I put them here, but just you understood, na? The value of R, like reactant is some value. After that, it is reducing to some value. So this is our reactant, green one. This is a product. This is a product. Okay. So we can say, suppose this is our reactant R. At T1, its value is R1. Okay. This y-axis is concentration, and this is x-axis is our time. Okay. So this is P is for product, R is for reactant. Okay. For T1, reactant value is at T1 it is R1. At T2 it is R2. Okay. Like you can see, its value is decreasing. Initially it was R1 higher value, and at T2 its value is decreasing. Okay. And if you think about this product, then you can see at T1 its value is P1, and at T2 its value become P2. So initially its value was P1. After that it will increasing to P2. So its concentration is increasing. Okay. So that is like from graph you can find out its value is increasing, for this one decreasing. Okay. I hope you understood with the graph also. Okay. So do you have any doubt? इसका डाउट है कुछ, और सेल वी गुड टू गो? ठीक है, तो हम चलो अभी देखते हैं. ठीक है. सो नाउ लेट्स सी एवरेज एंड इंस्टेंटेनियस रेट ऑफ रिएक्शन. We have come to know we have speed. Now we have two types of speed. One is average speed, and another is instantaneous speed. So let's see what is average speed and what is instantaneous speed. ठीक है. एवरेज होता है ना कि total by total, that is average. Okay, for example, this is our car. Okay, so it is moving from A to B. Okay, I'm always taking this A and B only, is it convenient? Okay, and there is a point C. Okay, na? And let's initial time is T1, final time is T2, and in between let's take this as T. Okay, so this car is moving. And let's the distance between them is, let me take the initial value, whatever the value I have taken. So this is 100 meter, and total time suppose it take is initial here suppose 0, and here suppose we have 20. So total time is 20 minutes. So for this scenario, what is the average speed and what is the instantaneous speed? Okay, so suppose here we have t equal to 15 minutes, for example, na? So if they ask you what is the speed of this car while it moving from A to B overall, so in that case we can find out speed. Let's denote it by V. ठीक ना? V, that is equal to total distance. Total distance is 100 A to B na? 100 by time is 20. That is equal to 5 meter per minute. So this is average, low, like averagely what is the speed with which it is moved. It is not like that throughout this journey it have 5 meter per minute is the speed, not like that, but overall if we see somehow it maintaining this speed. Okay, so it is averagely to cover A to B we need a speed of 5 meter per minute, 5 meter per minute. ठीक ना, that is our average speed. So what is instantaneous? Instantaneous means at particular time. Suppose they ask you what is the speed of this car at the point of C, or what is the speed of this car when the time is 15 minutes. Okay, suppose at that time its speed is suppose 8 meter per minute. So this is the instantaneous speed. At particular time, what is the speed? That is instantaneous speed. And average means throughout the journey, what is the like average speed, like that. Okay, so these are two terms. I hope you understood this. Average means throughout the journey, what is the speed? Averagely, if we take instant means at particular time, what is the speed? Okay, and it have, because the road is not smooth, so there is variation in speed. Okay, so if we take the average, you will get some value, but at particular time, it has also different value. I hope you everyone understood what is the instantaneous rate and what is the average rate. Okay, so based on this idea, let's see or understand this one with example of any graph, with help of any graph. Okay, to find out average rate of any reaction, to measure rate of reaction in certain interval of time. Suppose we have R reactant converted to product. Okay, so average we can write what is the total change of R with respect to time. That is average. Okay, so here we can write, because you are taking reactant, R is our reactant, so that's why I put minus sign here. After that, what is the change of R? Finally, its value is R2. From graph, you have seen this. This graph, you can see. Okay, final value is R2 at T2. Initial value is R1 at T1. So what is the change? We can write like this. Okay. So what is the like rate of the reaction? Always you will get positive. Sorry. With respect to reactant, you will get negative. With respect to product, you will get positive. Now here you see, if you see the change of product, you will get at T2 its value is P2 and T1 its value is P1. So we are taking the change like overall within this interval, what is the change of this R? That is average, not exact value, but averagely we can take this one. So if we want to find out instantaneous means like this. Okay, suppose we have some reactant whose value is changing from here to here, and it's taking this time. So if they ask you what is the concentration of this reactant at time equal to T1, this is in between 40 or 60 minutes, let's assume this is 50. So what is the concentration of that reactant in this? Okay, so this is 40 or 50. Okay, everyone understood this? So that is called instantaneous at particular point of time. What is the rate? And we can find out by drawing a tangent through this one, through this point. Okay. Or we can say, so if we look initially, we have taken for average, we are taking some interval, like within this interval, what is the change? That is our average. So if we reduce the time to some point, or we can say change in time tends to 0, or at particular time, what is the change? That is instantaneous, and we can, from graph, we can find out by drawing the tangent there. Okay, and by using that slope, we can find out what is the rate. This, or we can say the slope of this line is give you the instantaneous rate. Okay, or you perhaps study the differentiation. So if you differentiate product or reactant with respect to time, okay, then you can find out its rate at particular time. Everyone understood this? So from graph, we can find out like this. Okay. I hope you understood a difference between average and instantaneous. ठीक है ना? So do you have any doubt till now? Just let me know, or otherwise we can continue. Okay, so let's proceed. Na? Proceed. Okay, so please try to solve this one. So let me read the question. For reaction concentration product given its C equal to 2.5 T square minus 4 mole per liter, find average rate of reaction between interval T1 equal to 10 second and T2 equal to 20 second. Okay, and also find out the instantaneous rate at T equal to 12. T equal to 12. Okay, so now, so what we will do? First we will find out concentration C1. So let me write the equation first. C equal to 2.5 T square minus 4. Okay, so C1 how we will find out at time equal to 10 second. Just put the value of T1, this one, and you will get some value of C1. Like that, put the value of T2 and you will get some value of C2. Matlab, the concentration of this one at time equal to 20 seconds. Okay, you will get this one. After that, what is the total time? Total time equal to T2 minus T1, that is 10. Okay, so this is the total 10. So just divide this one. So you'll get C1 at T equal to 10 second and C2 at T equal to 20 second. So I will find out the average rate. Average equal to C2 minus C1 by T2 minus T1. If put those values, you will get the answer. And to find out the instantaneous rate, what we will do, just put this 12, time equal to 12 at this time. Okay, like this, 2.5, 12 whole square, okay, minus 4. You solve this one, you will get the answer. Everyone understood this? How to solve this? Like how to find out this average and instantaneous. Everyone understood, na? Or shall I solve this? I hope everyone understood it. Simple. Just find out the value of C1 by putting 10 equal to here, and C2, concentration C2 by putting 20 at this time. Okay, and take the change with respect to time, you will get the average rate. Okay. Everyone, I hope everyone understood this. Or do you have any doubt? Okay. Okay. So suppose we are given this example, this one, okay, nitrogen react with hydrogen and it will give us ammonia. Yeah, okay. From here we can see a change of NO2, sorry, nitrogen with respect to time. This is a reactant, so we put minus sign, that is 1 mole per minute. Because if we see this one, here it consumes 1 mole of nitrogen, it consumes 3 mole of hydrogen, and it will give us 2 mole of NH3. So if we write their change, okay, with respect to nitrogen, hydrogen, ammonia, then we can write 1 mole is, suppose let's take the time 1 minute. So in 1 minute, had nitrogen consuming 1 mole per minute, here 3 mole per minute and 2 mole per minute. So this is the what we say respective changes of this nitrogen, hydrogen and ammonia. Okay, so now we can say, suppose rate or speed, we can say change of nitrogen is 1 mole per liter. Suppose, or we can say, let's take this speed, this is x. So we can say N2 by like change of N2 with respect to time, this is 1x change. This is a speed, x is speed. This is mole per minute. This is let's speed. So hydrogen is changing is 3x, like 3 times of this x, 3x. Because they're consuming very fast, 3 mole per minute. And here 2 mole per minute, so its consumption rate is 2x. So whatever the x we are taking, this is a rate or speed. So if we want to get rate of this particular reaction with respect to nitrogen, hydrogen, and ammonia, then we can write we can write x equal to N2 by dt. This is minus. And here we can write x equal to speed of this reaction is 1 by 3 change of hydrogen with respect to change in time. And here change is 1 by 2 NH3 by D3 speed. So now if we equate x with everything, then you will get whatever the rate of disappearance of nitrogen, that is equal to 1 by 3 of disappearance of hydrogen, and that is equal to 1 by 2 rate of appearance of NH3. Okay, so if we equate them, then we will get this relation. So for any reaction, we can get this relation, like the relation between the rate of change of each reactant and product with respect to their coefficient. Okay, we can find out. Okay, so from here, if we take the relation between rate of change of nitrogen with hydrogen, then here we can see rate of change of hydrogen is here. If we take this this side, 3 times rate of change of nitrogen. That means what? Consumption rate of hydrogen is more with respect to nitrogen. Okay, this one. So let's see whether you have understood this concept or not with example. And for example, this is our reaction, some kind of reaction in which we are taking A mole of A, B mole of B, which give us C mole of C and D mole of D. Okay. So for this one, how to write rate of this reaction? So rate of this reaction can be written, rate of reaction with respect to A is rate of disappearance of A, okay, divided by coefficient of A. Minus and why minus sign? Because this is our reactant, its value is decreasing. And with respect to B, we can write rate of change of B with respect to divided by coefficient of B. Likewise, we can write for C and for D. Okay. Like why we are putting minus sign here? Because these are reactant, their value decreasing, and these are our product, their value is increasing. Okay, na? So if we put them together, then we can write rate of the reaction is like just take the rate of that particular reactant divided by its coefficient. Simple. Everyone understood, na? Everyone understood, na? Like this simple thing, like this is, we can say, one type of notation, like how, or one type of notation we can say, or way of writing. Okay? Rate of reaction for with each reactant and product. Okay. Okay, so for this one, I have already written this one. So can you try for this one? Everyone, just try this one, and after that we'll discuss. Okay, so like here we have mercury react with chlorine and give us HgCl2. So if we want to write rate of this reaction, so how to we put that? Hg rate of change of change of Hg with respect to time, we put minus sign because it's a reactant. Same for chlorine, change of chlorine with respect to time. And for this one, we are taking change of HgCl2 with respect to time. We put plus sign here because it's a product. So can you guys doing same thing for this one, this reaction? Just write this one and we will discuss. Or if possible, you can write in the chat also. Everyone understood this? Okay. Okay, so I hope you tried this one. So let's see this, how to write this one. Okay, so coefficient of Hi is 2, coefficient of H2 is 1, and coefficient of I2 is 1. Okay, I2 is 1. So here we can write rate of the reaction equal to rate of change of Hi divided by its coefficient with minus sign because it's our reactant. And for hydrogen, we can write H2 by D2, and for iodine, we can write I2 by D2. Simple. Okay, right? Rate of this reaction or speed of the reaction with respect to reactant and product, we can write by simply dividing coefficient of that reaction. You can just divide this one, you will get the. I hope you understand this simple concept. Or do you have any doubt? Batao, so that we can discuss. Okay, simple. So अब अगर if you understood this, so let's solve this one. चलो ये बताओ everyone. I give you 1 minute. चलो इसको solve करो everyone. YouTube. Anyone like which is the rate of change of B with respect to A? Anyone? This is the question of 2002 J question. No? Okay. So let's discuss this one. So from this equation, the equation is 3A give us 2B. So this can be written. I denote rate R with R. So this can be written minus 1 by 3. Why 1 by 3? Because coefficient of A is 3 and this is reactant. So I put minus sign here. So change of A dt equal to 1 by 2 dV by dt. We need the answer in the term of A for B. So we can write rate of change of B with respect to time equal to 2 by 3 rate of change of A with respect to T, and this is our minus. So which is the correct answer? 2 by 3 D by dt. This is the correct answer. Yeah, I hope everyone understood this. ये सभी को समझ में आया ना? Would you have any doubt? Okay. I hope you understood this. Okay, so let's proceed. देखो, if you have any doubt in between, just let me know. ठीक, we can discuss. Like in that case, I assume you understood this. ठीक, this one. इसका homework कैसे दिया? So वैसे टाइम हो गया. So let's take this as a homework. ठीक है, इसको आप homework के ले लेना. ठीक है. So here we are given. We have to find out. You are given in a reaction 2A is coming to product concentration of A decreasing from 0.5 to 0.4 within 10 minutes. Calculate the rate of reaction during this interval. Rate of the reaction, not the rate of change of A. It is asked as the rate of reaction, not the rate of change of A. Okay. So how will you solve this one? I will solve this. It asks us the rate equal to, we can write 1 by 2 rate of change of A by dt. ठीक है ना? So minus 2. What is the change of A? That is, it is changing from 0.5 to 0.4. So final 0.5, initially 0.5. Final it is 0.4, initial it is 0.5, and changing is 10 minutes. Na? 10 minutes. So we can write this one is, we solved this one, I think, na? Or not? I don't know. This one multiply 0.1 by 10. So we can write this is, sorry, here minus also. So we have 1 by 20 mole per liter per minute. ठीक है. So this one, or if we want to simplify this one, sorry, this is 200, na? 200, huh? So multiply divided by 5, you will get 5 by 1000, no? 5 by 1000 equal to 5 into 10 to the power minus 3 mole per liter per minute. I hope you everyone understood this, like how to find out rate of the reaction if you are given this. समझ में आया ना सभी को? Okay. चलो ये उसे लिखा गया है. So okay, so let's take this as a homework. इसको आप homework ले लेना. Solved है. ठीक है, फिर भी आप उसको next class में करके लाना. ठीक है. So मैं थोड़ा I recap the thing quickly. So here we have seen type of reaction: fast, moderate, slow, and after that we have seen rate of reaction in the term of reactant and product. And in rate also we have studied two types. One is average rate, another is instantaneous rate. So in average rate, we have taken the whole change with respect to whole change in like total change in time. Instantaneous, at particular change of time or particular time, what is the rate? What is the change? That is instantaneous. Or we can say if you take this delta t or change in time tends to 0, then you will get the instantaneous rate. Same thing for product. Okay. And we can write rate of the reaction with respect to this one like this. Okay. Rate of disappearance of reactant by stoichiometric coefficient. This one. Okay, I hope you understood this. Suppose we have A converted into CC, then we can write here minus A dA by dt, and product can be written 1 by C dC by dt. I hope everyone understood this. So do you have any doubt here till now? We have 1 or 2 minutes. If you have any doubt, just let me know. I can tell you. Or just go through the chapter of this chemical kinetics. Try to solve question of NCERT and that Avanti module till this concept. And if you have any doubt, just let me know. Okay, next class, or you can WhatsApp me. Okay, na? Suppose you have any doubt, take in the group. I can answer you. So if you understood this, then you can give me the thumbs up or you can leave. And we can wrap up the class. I think you have next class also there. Okay, so I'm stopping this one. So do you have any doubt till now? Anybody? Or we are good to go? Just give me the thumbs up and you can leave. Or are you people continuing with same ID? Okay. Okay, Chitradurga, Rangareddy, bye. So everyone, like study, okay, and let's meet tomorrow. Okay, everyone. Thank you.